So you're constructing a smart contract. You want to make sure everything's working as it should. The best way to do that is with tests. So grab your hard hats and let's dive in. Now, when it comes to testing, personally, I like to do test-driven development. That's where you write the tests, they're going to fail. Then you write the code that makes them pass. But in this tutorial, we're going to focus just on that testing piece. We'll use an existing smart contract that's already working, and we'll write tests to ensure it's doing what we think it is. We'll build a suite of tests around a basic NFT contract. So let's get started. All right, so let's take a look at the contract that we're going to be testing. This contract is pretty basic. It imports some contracts from OpenZeppelin. If you're not familiar, they're one of the most battle-tested sources for contracts out there right now. It essentially is just a mint function for an NFT that is called award item. So it's a game item. Now, when it comes to testing this contract, there's a few things that it should do by default, right? We're talking about an NFT contract and we want it to be able to mint an item. So that's probably the first thing that we should test to make sure, hey, does our contract mint an item? Next, when it mints that item, does it assign it to the correct person, the owner of that item? So we should check that. When we also are minting our item, we want to ensure that our token URI is set correctly. These are kind of the basics for an NFT. We want these things to function. And finally, that piece of ownership when it comes to NFTs comes in, and we should be able to transfer our NFT as well. So we need to test all four of those things. Those are things it should do. Now, we also might want to look at things that it shouldn't do. It's good to always test to make sure that your code does what it should, but it's also important to make sure that it doesn't do things that it, well, shouldn't. So if we think about transferring the token, we definitely don't want someone who's not the owner of that token to be able to transfer it. That's something we test. And finally, the last test that we're going to implement is going to be one to change this code so that only the owner of this contract can mint new tokens. I mean, they are game items. You'd probably hate to have some player minting something like the Holy Hand Grenade of Antioch or something like that in your game that's way too overpowered. So let's look at how we are going to do that. When it comes to hard hat, the first thing to know is that if you run npx hard hat test, you should see the tests that are currently there. And you'll notice this starter project here has some tests for Greeter. This Greeter contract here just sets a message, and we have our tests in the test folder under index.ts, and it describes the Greeter function and what it should do. We can use this same kind of framework in our tests. So one thing to know is that when Hard Hat runs its tests, it's going to run everything inside this test folder. So create a new file here, and we'll call it game item test.ts. When it comes to our test contract, there's a few things that we need to import first. We'll need to import load fixture. What that'll do is it'll let us actually run a set of commands before each of our tests. So things like deploying the contract, minting an NFT, we'll do that before each of our tests. One cool thing about Hard Hat is it actually saves the state of the blockchain to speed up your test. So it doesn't have to repeat that process every time. It takes a snapshot and pops back to that snapshot before every test. We'll also load in expect. That way we can expect the results. And finally, ethers so that we can interact with the blockchain. So the first thing we're gonna do is we'll describe our tests. So we'll call it game item contract. You can call it what you want. If you look at the example that they provided for us, they called it Greeter. That was just the name of the contract. And then we'll use that load fixture piece. So we'll create an async function called deploy token fixture. In there, we're going to do a couple of things. First, we'll use ethers to get our contract factory. That'll be the actual contract Solidity file. And the contract within there called game item. And we will await for that to be deployed. And we'll store that result in our game item value. Once our contract is deployed, we'll go ahead and grab a couple of things from ethers. We'll grab the owner, address 1 and address 2. We'll use these later on in our tests. Essentially, what Get Signers does is it provides us with all of Hard Hat's signer addresses. So all the different wallets that we can use within Hard Hat. Owner is going to be who deploys the contract. Address 1 and 2 are just two other addresses that we can use. And finally, we'll wait for our actual contract to be deployed before doing anything, and then we'll return a few values from this function that we can use in our tests. Great, so we've got this set up. Remember, this will run before each of our tests. Once this is set up, we want to do one other thing before each of our tests. And I'm kind of skipping ahead, but as we go through the test, you'll see why we're doing it here, just to kind of keep things dry. We don't want to repeat ourselves. Go ahead and mint our NFT in this token fixture. We pass in the owner address as the person who's going to be minting the NFT to. And then we pass in a URL for our token URI. This is just an example. There's nothing there right now, but that's okay for testing purposes. And finally, we wait for that minting transaction to finish. Cool. So we have our entire contract deployed. We've minted a token and we're ready to test. Let's write that first test to make sure that the minting actually took place. So it should mint a new token, right? That's the first thing that we want to do. When we say it, we describe what it should do in our test. You'll see how that looks in just a minute and when we run the test. And then we get the game item that's going to be that contract and the owner. And we wait for that to be done in the load fixture. And then we expect the balance of the owner address to be 1. That means they have 1 token now. So we give this a save, and down here we can run npx hardhat test. And you'll see our greeter still runs, but we have our game item contract now. And it should mint a new token. We get our green check mark. That means it's working. That means we actually have minted a token now. Fantastic. So what was the next thing that we wanted to test? If it sets the owner of that token correctly. How would we do that? Well, create a new test. It should set the owner of the token. And again, we'll go ahead and wait for that load fixture to run. That's the thing that runs before each of our tests. And then we'll expect the owner of token 0 to be the owner address. Now, what if we wanted to check and see if it was a different address? We could pass in address1.address here. And that would make our tests fail. So if we did this and we run it, we can see now, hey, our tests are failing. And it even tells you why they're failing. Expected this address to equal a different address. That's not good. So this is a way that you can ensure that your tests are actually working. We'll go ahead and put that back and give it a save. And we'll run our tests again, just to make sure everything's working. Cool, so we can mint a token, and we can also ensure that the owner of the token is set to the correct address. Next, we wanna make sure that that token URI is loading correctly. So we'll create a test for that. It should set the token URI. We know what it's going to be. It's going to be that game.example item id1.json. So we'll create our token and we'll mint it, and we'll go ahead and check that the token URI equals what we expect it to. And again, we'll run our tests and make sure everything's working. Fantastic. So we mint a token, we know who owns the token, and we've set that token URI. The next thing that we want to test is that we can actually transfer a token. Now, this gets a bit more interesting. So far, we've just been minting a token and expecting the results to be what they are, right? Now we're going to actually interact with the contract a little bit more. So what we'll do is we will mint our token, and then we will transfer that token. So we're going to be interacting with that contract here in our test. So we get our constants of the game item, the owner, and address 1. So that'll be a different address than the owner of the token once it's minted. And then we'll transfer that token. So we'll use the game item, which is the contract, dot transfer. So that's a function within the contract. And we'll pass in the owner address, so the from, and the to, address1.address, in which token we want to transfer. So that 0 token, the first token. We'll wait for that to be done, and then we'll expect the owner of that token to now be address 1. And what's really cool is we can look above here and see that previously we had tested it and expected the owner to equal the owner.address. So now it should be different. So let's go ahead and give this a save, and we will run our tests again. Fantastic. You can see here that should transfer token is a green check as well. So that's working as well. Awesome. So we've tested the basic functionality of our NFT here and ensured that things are working the way that they should. We may want to check and make sure that someone who's not the owner of the token can't transfer it though, because that'd be bad, right? If anybody could transfer that token. This will add another piece to what we can test with hardhat. So far, we've only been using the owner address. What if we need to act as a different address? How do we do that? Well, let's take a look at this test. So it should not transfer the token if you're not the owner. That's the test we're doing. And we'll have our constants again that we're getting from our load fixture, and we'll do an await expect. And what we're going to expect is an error to happen. So let's break this down. We've got our game item, and then we connect to it as address 1. This is a key thing. We now are changing our wallet from the owner address to address 1. And then we'll transfer from the owner to ourselves that token 0. So we're basically saying, hey, that's a nice token you've got there. I'd like to transfer it to me. That shouldn't happen. We don't want that to happen. So we expect this to be reverted with an error. And here's the error that it'll be: ERC 721, caller is not token owner or approved. So we expect this to revert. We expect this transfer to fail. So this is how you can test something that is not supposed to happen. So we give this a save and make sure that our tokens are safe. Great, so it doesn't transfer the token if we're not the owner. We talked at the beginning about how maybe we want only the owner of this contract to be able to mint NFTs. How do we test that? That's not in the functionality of this contract currently. If we create a test that it shouldn't mint if you're not the owner, again, we'll use that same thing. We'll use that connect as address 1, and we'll go ahead and run award item, which is our mint function. And we'll pass in ourselves as the address, and we'll go ahead and pass in a token URI. We figured out how this works, and we want to mint this token to ourselves. And we want this to fail, so we want to expect it to be reverted with an error. Say, hey, the caller is not the owner. So let's save this, and we'll see what happens. All right, so our test fails. Now we're getting into how test-driven development works. I've written this test, let's make it pass. So we have this failing test. We expected the transaction to be reverted. It wasn't. Anybody can mint a token right now. So how do we fix this? If we head back into our contract here, we'll need to do a few things. Now, we're using Open Zeppelin contracts already, so let's go ahead and import one more, ownable. This will give us access to things like only owner, which is a modifier to enable us to ensure that only the owner of the contract can call it. And it also will allow us to set the owner of the contract. So when we import this, we need to say that our contract is an ownable type. Just like we have ERC 721 URI storage here, we also need to add ownable. So now we're bringing in that ownable contract and all of the great things that it provides. And finally, the last thing that we need to do is in our function to award the item, we need to say, hey, only the owner can do this. So we'll add an only owner modifier here, and that should be it. If we give this a save and we run our tests again, we should see that yes, everything is passing now. Fantastic, awesome. That's basically it. You know the basics of how to test with Hard Hat now, how to get started at least. From here, you can dig into the Hard Hat documentation and start testing more. There is a ton that you can do with Hard Hat testing to ensure that your smart contracts are doing what they're supposed to and not doing what they shouldn't. Tests are also a great way to ensure that you haven't broken any functionality when you make changes to your contract. Thanks for watching, and I'll catch you in the next one.